Good afternoon to all. Okay, how are you? Fine? Okay. Any doubt in last class? No. Okay, now listen properly. Now we are going to discuss about one of the famous and repeated 100% important 5-mark question. Okay, that is vertical oscillations of a spring. Come. Vertical oscillations of a spring. Famous and interesting question this. 100% repeated question. Okay. Five mark. Okay. Listen here. Listen properly the method of drawing the diagram. Okay. One by one. Listen here. Mass M. Okay. Listen step by step. Okay. Small. Then mass M. This is L. This is Y. It is equal to L plus small l. Okay. Okay, listen. One of the famous and interesting question. Okay. MG. Okay. Diagrams. Okay. That is very, very important because to writing without any mistake, that means the derivation diagram is very, very important. Okay, listen. Let us consider one massless. What? Massless. That means a negligible mass. Consider one spring of massless and of spring constant K. One end of the spring attached on a ceiling. Okay. Then this is other free end. Then length of this spring before added mass with it is equal to capsule. Okay. It's a spring constant K. What is meant by K? Yes, very good. Spring constant. Okay. Then here one mass added with this spring or with this end of the spring. Compulsory this spring just elongates. I am correct or not? What is the reason? due to added mass m with this end of the spring. Okay, so just after added mass with this spring, just this is elongates with the displacement small l due to mass m. That means the stretching from this position. Okay, now total length it is equal to, yeah, very good, l plus small l. Okay, so listen here. Due to stretching of the spring, very good, one of the restoring force set up on the spring. Okay, just consider that restoring force F1. What is F1? Very good, restoring force. This restoring force is directly proportional to elongation of the spring. Okay, therefore F1 is proportional to small. Okay, yes. What is the reason for restoring force? Very good, mass added with it. So one of the gravitational force, very good, acting on this mass vertically downwards. That is Fg is equal to mg. Okay, then at equilibrium of the system, that means this position, there is no oscillation, equilibrium. Okay, under the equilibrium condition of the system, very good, F1, you can draw one free body diagram. Listen here, m, this is a restoring force F1, this is gravitational force mg, under the equilibrium condition, very good, F1 is equal to mg. Okay, but opposite direction, no? Yes, F1 is equal to mg, but both are opposite directions, so F1 is equal to mg. Okay, then formula for restoring force, F1 is proportional to L, no? Very good. Or F1 is equal to, you must one of the constant, no? Yeah, that is called K. K means here spring constant. This restoring force compulsory will be opposite to the displacement of the spring. Clear? Yeah. Come, very simple question this. So F1 plus from this mg is equal to 0, no? Very famous and interesting question. Listen one day. Okay, sir, what is the motivation of this question, sir? Yeah, motivation of this question to find time period of oscillations. Simple for this capacity. Okay, yeah, come. F1 plus mg is equal to 0. Okay, F1 value, very good, minus K plus mg is equal to 0, or minus KL minus mg minus KL is equal to minus mg, minus minus cancel, so what is the remaining? KL is equal to mg, or mg is equal to KL. Okay, very very important equation this. Or m by k is equal to L by G. Okay, that's all. Okay. The next, listen here, very simple this. M by K is equal to L by G. Okay, now mass M added with other end of the spring. Okay, this end attached with the ceiling, no? Yeah. Okay, here. Now, just one external force applied on this mass, or just pulling this mass, pulling this mass. Okay, so due to applied external force on this mass, or just pulling this mass, yeah, this is just moves up and down, just oscillates up and down with the acceleration, a. This is the acceleration of the mass. Okay? I am correct or not? Very simple. So it is equal to d square y by dt square. Consider this displacement only. After applying external force on it, from this position, just further or again this mass, applying external force on this mass, the spring further elongates with the displacement to y. Okay? Just oscillates up and down with the acceleration a is equal to d square y by dt square. You must consider this displacement only. Okay. Again, by pulling this mass, again that means gravitational force acts vertically downwards. One of the restoring forces set up in the spring, that is called F2. Okay. Now total elongation from this position, or total displacement from this, yeah, very good, L plus Y, that's all. So total extension is equal to Y plus L. Okay? Yeah, very good. From this, like this equation, restoring force is proportional to total displacement, no? Yeah. Y plus L. Very simple this. All are derivation. Very, very important, repeated 5-mark question. Listen to F2 is equal to, yeah, we must add another constant, no? And minus Y plus L. This is after applying, yeah, external force on the mass. Just a pulling. After pulling, this mass just oscillates or moves up and down with the acceleration. A is equal to d square y by dt square. Okay, so F2 is equal to now minus ky and minus k. Okay. Yeah, one equation, famous equation borrowed from Newton's second law. F is equal to ma, no? Total force, total mass, total acceleration. Mass, okay, m. Yeah, m, only m. A is equal to, yeah, already written in the board. Total force, now total force, very good. Again, one free body diagram. FBD, after applying external force, this is mass m, now this is F2, this is mg. Okay, so F2 is equal to minus k of y plus L, no? Yeah. So now total force F2 plus mg is equal to 0. Okay, like this, at a mean position or equilibrium condition. Okay, that means now at equilibrium condition y is equal to 0, no? Yeah. At equilibrium or mean position y is equal to 0. Okay, like this or like this. From at this point, displacement is 0, no? Yeah. Like this y is equal to 0. Now total force F2 plus mg is equal to 0. Or, sorry, here F2 plus mg is equal to 0, okay. But at equilibrium condition at the same time. But here at equilibrium condition, this only okay. Consider. Then, when acceleration A After applying external force on the mass M, oscillates, no? Yeah. Now consider this position. So F is equal to MA. This is total force. For M, okay. For A, okay. From F is equal to MA. Clear? Okay. Now F2 value, yeah, minus Ky minus Kl plus Mg is equal to M. Yeah, A value, very good. After applying external force on the mass M, just this spring oscillates or moves up and down with the acceleration. A is equal to d square y by dt square. Very famous equation. Already you studied. Come. D square y by dt square. That's all. Okay. Now minus ky minus kl. Yeah, mg value. Very good. Mg is equal to kl. Mg is equal to kl. Okay. Is equal to m d square y by dt square. That's okay. Now very simple. That's cancel. Okay. So what's the remaining is equal to m d square dt square. Okay. Minus ky is equal to m d square y by dt square. Okay. Yes. Now from this m d square y by dt square is equal to minus ky. Okay, minus ky. D square y by dt square is equal to minus k by m into y. Okay, listen here, this equation. Any idea in your mind? Any idea? You? What? Displace it. Very good. This equation is in the form of, very good, simple harmonic motion. What? Simple harmonic motion. Very good. Simple harmonic motion. In simple harmonic motion, basic formula for acceleration. Come and tell me yourself. Don't know. Okay, leave it. You? What? Very good. Very good. A is equal to minus omega square y. Very good. That's it. Clear or not? Absolutely correct. Very good. So, okay. So from this minus omega square y is equal to minus k by m into y. That's all. Okay. Minus cancel. Y cancel. What is the remaining? Omega square is equal to k by m r. Omega is equal to root of k by m. That's all. Already told you now. What is the motivation of this question? Yeah, to find time period of oscillations. Very good. So come, omega is the root of k by m. No. At the same time, we have one of the famous simplest formula for omega. Very good. What? U. The formula for omega. U. Very good. 2 pi mu. Correct. So omega is equal to 2 pi mu. Mu is equal to 1 by t. Very good. So omega is equal to 2 pi by t. From this, or omega is equal to 2 pi of 1 by t after substituting new value in this formula. Okay, so come. So omega is equal to 2 pi by t. Okay, yeah, come, substitute. Come here. That's all simple. So 2 pi by t is equal to root of k by m. Okay, or 2 pi by t is equal to root k by root m. No, yeah, we can split it like this. T by 2 pi is equal to root m by root k. T by 2 pi is equal to root of m by k. Okay, t is equal to 2 pi into root of m by k. In seconds, this is the repeated and very famous formula for time period of vertical oscillations of a spring. Already told you, simple no? Yeah, full and full derivation. Come here. See one by one. See one by one. Any difficult in this question? Yeah, very good. No, simplest question. Come here. So, famous and important formula for time period of oscillations. T is equal to 2 pi into root of m by k. Okay. Then come listen. Come here. Come from here. From here. Quick. From here. From here. From here. Okay. T is equal to 2 pi root of m by k, no? Very good. Listen here. Or taking square on both sides. T square. Taking square on both sides. T whole square, okay, T square. 2 pi into root of m by k whole square is very good. 4 pi square into m by k. Okay, then okay, at the same time, from this t is equal to 2 pi root of, for m by k, come here, yeah, very good. For m by k, L by g, no, yeah, substitute. Here substituting this value, come in this equation. In this is, leave it, keep it, no problem. In this equation, t is equal to 2 pi, m by k is equal to L by g, no, okay. That's all. T is equal to 2 pi root of L by g. Now taking square, taking square on both sides. T square is equal to 4 pi square L by g, no? Very good. From this equation, formula for g, what is g? Acceleration due to gravity, no? Yeah, very good. G is equal to 4 pi square into L by t square. Very good. Unit for this? Meter per second square. Read out. Very, very famous and interesting question. Okay? Yeah. See, go through fully. Go through fully. Come, one by one. Come here. Here. From here. Okay. Finished? Come back. Okay? This is the G value. Any doubt? Agree or not? This is very, very simplest and interesting question. Agree or not? Agree. Okay, thank you.